In this video, we will be going over how to factor by grouping. And we know to use factor by grouping when there are more than 3 terms in our polynomial. So let's take a look at this example first. So the first thing, no matter what, you want to check if there is a GCF. That's what you always do first, no matter what factoring problem you have. So we're going to look at 12, 9, -9, 4, and -3. We need to look at those numbers and ask ourselves, is there anything that divides into all 3 of them? And in this case, there is not. So then the next thing, we are going to pair up the terms. Now that we have our polynomial paired up, I'm going to pair the first 2 together. I'm going to ignore this part of the polynomial, and I'm just going to focus on this part here. So I know that 3 goes into 12 and 9. And I know that the smaller exponent would go out in front here. And then 3 times 4 gets us this 12 right here. And then x squared times x, these two together here, would get us the x cubed here. Then we have 3 times -3 would get us the -9 part here. And then it already has an x squared, so we don't need anything else there. Then we look over here and we ask ourselves, what can go into 4 and 3? There's nothing, so 1. And they don't have any variables in common, so it's just 1. So 1 times 4x would get us 4x. And 1 times -3 would get us the -3 here. So this has to be a positive 1. Now if we do this correctly, and it is able to be factored by grouping, then these should be the same. And if they are, then they have it in common. This and this has 4x minus 3 in common. So we're going to bring down the 4x minus 3, and then we are going to pair together the 3x squared and the positive 1. So we're going to bring that here and pair it together. So this is our factored form. Now let's say we want to check this. So to check this, we would multiply it out. So 4x times 3x squared is 12x cubed, and 4x times 1 is 4x. -3 times 3x squared is -9x squared, and -3 times positive 1 is -3. So when we multiply it out, we get this. So 12x cubed minus 9x squared plus 4x minus 3. And if we go back to our original problem, that's what we started with. So you can always check this by multiplying it out and check if we get the original polynomial, which we did here. Okay, so let's try another one here. So first of all, we ask ourselves, is there anything that goes into 2, 5, 6, and 15? Is there anything that divides all of them? And in this case, there is not. And then we look at the variables, they don't have an x in common. So now what we're going to do is we're going to do our pairings. So we look here, and there's a 2 and a 5, and nothing goes into 2 and 5 other than 1, but they have x's in common. So we take the one that has the smaller exponent, which is x squared, and then x squared times 2 would get us this, and then x squared times x would get us the x cubed part. X squared times positive 5 would get us this, and then x squared, we don't need anything else, so if we distribute this here, we'll get this. Now we're going to do the same thing over here, so we need to ask ourselves what can go into 6 and 15, which is 3. And they don't have x's in common, so we're just going to pull out a 3. And 3 times 2 is 6, so we're going to put a 2 here, and then we need the x. and then 3 times 5 would get us the 15. So this has to be a positive 3 to get this here. So now if we did this correctly, this should match up to that. And if it is, we're going to bring that down. We're going to factor out the 2x plus 5 essentially. And then we are going to pair the x squared with the positive 3. And we have our factored form. Okay, if we take a look at this example, first of all, again, we always ask ourselves, is there anything that goes into 3, 4, 9, and 12? So there is not any number other than 1. So now we look at the variables and ask ourselves, do they all have variables? Which they do not. So now we're going to pair up our polynomial here. So if we pair up the first two, what can go into 3 and 4? Just 1. And then we look and see if they have variables in common. So this one's the smaller one, so we're going to put an x squared on the outside. And then x squared times 3 would get us the 3 here. And x squared times x would get us the x cubed part. X squared times negative 4 would get us the negative 4, and then it already has the x squared here. Okay, now here, what can go into 9 and 12? That's 3. And 3 times 3 is 9. And then we need the x to make this x. And then 3 times 4 gets us positive 12. So now if we look, these are not the same. This is a negative 4, and this is a positive 4. And also right here, this should have been a negative there to make the negative 9x. So they're not identical. So what that tells you to do is instead see what happens if we make this a negative 3. So if this is a negative 3, the negative 3 times 3 gets us this negative 9x here. And then negative 3 times 4, negative 4, would make this positive 12. So we need to change this to a negative 4. So that again, then you would have negative 9x plus 12, which is what we have up here. Okay, now that these are the same, then we're going to factor it out since they have it in common here. And then we're going to put the x squared and the negative 3 together. And that is our factored form. All right, last example. Let's go ahead and take a look at this one here. So we ask ourselves, is there anything that goes into 12, 28, 15, and 35? And in this case, there is not a number that goes into all 4 of those terms. They all don't have x's, and they all don't have y's. So now we're going to do our pairings, and we have to think about what can go into 12 and 28. So I know 4 can go into both of them. And they both have x's in common. So I'm going to pull that out. So now 4 times 3 is 12. And we already have the x there and the x here, but we're missing the y, so we're going to put a y here. Then 4 times negative 7 gets us negative 28, and then the x again is already here. Now we come here, and I know 5 can go into 15 and 35. And 5 times negative 3 would get us this. But then these won't match up. So now I'm thinking, what if I made this a negative 5? If that was a negative 5, then this would be a positive 3, and they would start to match here. Because negative 5 times 3 gets us the negative 15, and then we need the y there. And then negative 5 times negative 7 would get us the positive 35 there. So we need a negative 7 there. Okay, now we have that these are identical. So we're going to pull out the 3y minus 7. And then we're going to put the 4x and the negative 5 and pair them together. And now we have our factored polynomial. Okay, if we take a look at this example here, we're going to do one more here. We first ask ourselves, is there anything that goes into 6, 6, 12, and 12? So the GCF, the greatest common factor, would be 6. 6 can go into all the terms. So we're going to put the 6 in the front, and we're going to factor it out. And notice they have no variables all in common, so it's just the 6 that's the greatest common factor. So we have an x cubed here, an x squared here, a 2x here, and a 2 here. So I just divided everything by 6. Okay, now to factor by grouping, we're going to pair 2 together. So I'm going to pair those 2 and those 2 together and see if it works. So if I pair these 2 together, they have an x squared in common. Now this 6 just will stay and go and be in part of our final answer here. So it's in our answer, so I'm going to bring it down so I remember this 6 isn't going anywhere. So then I have x squared times x would get us the x cubed, and x squared times 1 would get us this. Then I come over here and I know that 2 can go into both of these. And 2 times x would get us 2x, and 2 times 1 would get us 2. So if we did this correctly, these should end up being the same thing. And when they are, we're going to factor it out, and then put this and this together. And that would be our factored, whoops. Let's go ahead and move this 6 so it's closer. This would be our factored form. So let's say we want to check our answer. Does this really factor or multiply to this? So to check it, we would distribute. And then we would take that and multiply it by all of this. So now we have 6x times x squared, 6x times 2, 6 times x squared, and 6 times 2. And if we move things around, we would have 6x cubed, and then 6x squared, and then 12x, and then 12, which this is what we had started with. So that just is proving that we correctly factored here.